In order to understand what NoSQL is, it's really important to sort of take inventory of the conventional relational database model that we work with today. And if we take a look at the slide here, we have a customers table, a rather simplified kind of typical example of how relational data works. And in this case, we have a table. The table has two rows. You can think of rows as records in a database. And we have several columns, 7 in all. And the columns are really the fields in the database. So we have an ID, a unique ID field, and then we have actual data fields for the last name, first name, address, city, state, and zip. We have exactly the same structure between rows. There's no variability there at all. And the way that relational databases work is that typically you have multiple tables, and oftentimes you have relationships between those. So we could imagine another table that had orders, and once again, we have an ID field, and we also have data fields for amount, for tax, and for the ship date of the order. I skipped over one field though, that's the customer ID field, and if you look at the numbers in those fields, you see that they reflect the same numbers that we saw in the ID field of the customers table, which is to say that those first two orders belong to customer Andrew Brust, and that third order belongs to customer John Doe. There's a one-to-many relationship between customers and orders, and that relationship is explicit and managed by the database. So again, this is an inventory of where we are with conventional databases. If we switch over to NoSQL, though, things change a little bit. Rather than having rows and columns, we do, in the parlance of some NoSQL databases, still have rows. But within each row, we may have a rather different structure. You'll actually see that if you look carefully at this slide. The first four fields, which are really identified in this case by keys that are then followed by a colon. Those first four keys, ID, LNAME, FNAME, and address, are the same for both. But if you take a look at the last three, you'll notice that in one case we have a city, state, and zip, and in the other case we have a village, a county, and a postal code. And we have an American address in the first place and a fictitious English address in the second case. Specifically, we have village, county, and postal code in that second row that simply don't exist in the first row. And if this were a conventional relational database, we would in effect need 10 fields to reflect all of these. And for a given row, 3 of those would be empty, and for the other row, 3 different ones would be empty. That creates a certain inefficiency, and of course, anytime we need to change the structure of the database, things can get a little bit brittle in a relational database, but here in the NoSQL database, we can just add it on kind of an ad hoc basis. Here's our orders table, and we've created an even more extreme example here, where we actually don't just have different keys in each row, but we actually have different numbers of keys. And that can be the case as well. So you'll see that we have a couple of blanks. Those blanks aren't really blanks, they're just things that don't exist. And speaking of things that don't exist, there's no explicit relationship. Now we have 1122 as the ID in the first customer row, and we also have it as the customer ID in the first two orders. But that's simply going to be by convention in programming that we understand that there's a relationship there. There's nothing in the data structure really that allows us to express that relationship. There's all kinds of data really due to the socialization of data, the movement of databases out of the business realm that may fit nicely in NoSQL databases. Addresses we've looked at, personalization data. Imagine you're logging into a news site for a major search engine, and the different keyword sections that you have and the different topics, be it world news or sports news, and the positions on the page where you have those things, well, that data has to be stored somewhere, and it has to be retrieved. It's not really very complex data, but it's very important data. Documents are an excellent example of things where we have data. It's just structured a little bit less consistently than it would be in a conventional database. But it's still important to have a database to track that data if we can. The whole social graph, the whole social media space maps very well onto NoSQL databases. So things like our network of friends and followers might be stored in a NoSQL database, and so might just random notes, for example. Now, it's not to say that in each of these cases, these particular kinds of data always are, or even best are stored in a NoSQL database, but in many cases, it can be a good fit. Another reason for NoSQL databases, and we'll get into this with a little bit more substance in a minute in the next module, is that we now have websites that are public consumer facing that actually have to accommodate as many as 1 million or even multiple millions of concurrent users. So even if they have relatively simple data needs, like retrieving personalization information about which news section should go on which part of your web page, even those simple needs need to be fulfilled very, very quickly, or else the site's not going to scale. The so-called web scale that a lot of sites with big brand names like Amazon and Google face is something that relational databases weren't really designed for. And so web scale and the whole kind of culture around web sites and web startups is a big part of the reason NoSQL has become so popular. Because in these particular use cases,